Hey, my name is Dignesh, and this is going to be lecture number 10 in the math lecture series. Today we'll be going over quadratics, which is pretty prominent on the SAT. So the first topic on quadratics is basically roots. Is the same as the x-intercept or solution for the quadratic, or there's multiple terms for it, but basically it's the x value from when y is equal to 0. And if you have a quadratic in the form of ax squared plus bx plus c, you could solve it using some methods we talked about in previous videos, like the factoring where you do x plus k times x plus h, where k and h, the product is equal to c, and the sum is equal to b. However, there's also the quadratic formula, which is a new thing we're learning, where x is equal to negative b plus or minus square root of b squared minus 4ac, and all of that is over 2a. So here you just plug in ABC values and you solve for x. And usually you'll get two answers. However, we'll talk about later how you can get one, or how you can determine you're going to get one or zero answers. So yeah, and you can also find the sum of the product of the roots using formulas such as sum is equal to negative b over a. So this is the sum of all the roots is equal to negative b over a, and the product of all the roots is equal to c over a. And yeah, and you can also have it in intercept form. Y is equal to a times x minus h times x minus k, and h and x are both the roots or x-intercepts of the equation. Okay, now we have the vertex. The vertex is like the midpoint. So like if you had a parabola like this would be the vertex right there. So yeah, so it's the midpoint, and you can solve it by you can solve for the x value of the vertex by doing x is equal to negative b over 2a. And this is obviously if you have an equation in this format. And then you can also then plug that x value into the equation to solve for the y value, and that the x and y value together is your vertex. And also a vertex you can also have a formula quadratic in vertex form, y equals a times x minus h squared plus k, where h comma k is the vertex. Remember, like if it's x minus 2, the vertex plus 1, it's 2 comma 1, not negative 2 comma 1. It's minus h. So yeah, that's a common mistake that can happen. And your y value of your vertex can be referred to as the minimum if it's upwards facing like this, or maximum if it's downwards facing like below. Next, we have the discriminant. Discriminant is b squared minus 4ac, which if you can recognize it, it's because it's in the quadratic formula, this part without the square root. So if this b squared minus 4ac is positive, then you have two real solutions. If it's negative, then you have zero real solution side. And if it's zero, then you have one real solution. So yeah, so you can use a discriminant to find how many solutions is without actually solving for the equation. And now I have attached a couple of practice problems. And as usual with all the other notes, these notes are on Google Classroom. And if you're watching the video, the Classroom code is in the description below. And I suggest you join a Classroom where you can find these notes and all the other notes for all the videos. And with them is a problem set. I'm only going to do like two of the problems just to give you an idea of the type of questions you'll see. However, I suggest you go even before, like maybe pause the video right now and go do all the problems and then come back and then you can see the two questions I do, and you can also check all your answers using the answers which are at the end, and they each have like a mini explanation too. But if you have any further questions, always feel free to always contact us. Yeah, so the first question we'll be going over is going to be number 5. What is the sum of the solutions of 2x minus 3 squared equals 4x plus 5? Here, instead of solving for the solutions of the quadratic or whatever, here just first expand all this and put everything on one side. So that would be 4x squared minus 2 times negative 3 times 12, which is minus 12x. So it's to find the middle value, is 2 times this value times this value. So 2 times 2 is 4, times negative 3 is negative 12x, plus 3 squared, which is 9, equals 4x plus 5. And now I just solve 4x squared minus 16x plus 4. And remember, the sum of the solutions of this is just going to be negative b over a. So negative b would be 16 over a, which is 4. So the answer is 4. And the other quick one I'm going to be going over is going to be number 11. So we have these two equations right here. And in the system of equations above, a is a constant. For which of the following values of a does a system of equations have exactly one real solution? So what I first want to do is I want to substitute the y equals negative 3 in. So negative 3 equals ax squared plus 4x minus 4. Let me move that negative to the other side. So 0 equals ax squared plus 4x minus 1. And now I want to know for which of the following values of a the system should have exactly one real solution. So that means the discriminant has to equal 1, right? If you want one real solution. So if the discriminant equals 1, then that means b squared, which is 16, minus 4 times negative 1. So that's plus 4 times a. So plus 4a equals 0 because I want to have one solution. So in this case, a would have to equal negative 4. So the answer is answer choice A. So yes, I hope this gives you just a taste of the quadratic questions. Obviously, there's a bunch of questions. I highly recommend you do all these problems because, as with any topic on the SAT, the more practice problems you do, it helps you much more than like a usual math test. Because in this case, the most questions you see on the SAT, like the question types have already been asked before in previous SATs, or like you can see in practice tests. So doing more and more practice problems can help you to be familiarized with these practice problems or like question types. And so when you see these question types on the SAT, you can be more efficient on answering that question. So yeah, that's it. That's basically it for this topic. I hope you learned something, and once again, wish you the best of luck on your SAT adventure.